So, this class I will discuss that how we can determine the ultimate lateral load for a pile if it is in cohesionless soil. So, in the cohesionless soil, the assumptions are main assumptions are. So, this is also based on the Brom's theory. So, main assumptions are that the active earth pressure contribution we will not consider. So, the active earth pressure contribution is neglected. Acting on the back of the pile is neglected. Okay. So, this is one assumption. So, we will consider only the passive pressure which is acting along the pile. So, and we have considered that the soil pressure at a point Pu is equal to 3 times of sigma v bar and the Rankine passive earth pressure coefficient. This is also one assumption. So, at a point, so sigma v is gamma dash into z, okay, gamma dash into the effective unit weight of the soil into gamma z, and Kp is the Rankine earth pressure coefficient, passive earth pressure coefficient, which is 1 plus sin phi divided by 1 minus sin phi, okay, and phi is the friction angle. So, this is another assumption, the soil pressure at any point is 3 times of sigma v dash into Kp. And another assumption is the shape of the pile has not considered. So, shape of the pile effect is not considered. So, for the any shape the distribution will be same. So, this way if I start with the this whether it is a free headed or fixed headed, the assumptions are same. So, first one we will call for the free headed piles, and first one is for the short pile. Okay. So, remember that in case of cohesive soil, we assume the uniform distribution of the soil pressure, okay. But in case of cohesionless soil, the distribution is not uniform, it is linearly varying with the depth, or it is varying with the depth. Okay. So, this is the major difference between the earth pressure of cohesive soil and the cohesionless soil. So, cohesive soil we assume the uniform distribution of the earth pressure or the soil reaction, but here we will assume a varying distribution of the earth pressure or the soil reaction. So, for the short pile, this is the ground surface. So, similar to our cohesive soil case, here also for free headed pile it will rotate with a point okay, it will rotate with a point. An assumption is that as we have assumed and it is mentioned that active earth pressure contribution will not be considered. So, the assumption is that the rotation is very close to the toe of the pile or the base of the pile. Okay. So, and here H u is acting here with the E value, with a value of E, and this is the L is the length of the pile. Okay. So, this is the deflection and the soil pressure will be, so it will act linearly, so it will vary. and as it is mentioned that the assumption is that we will not consider the active earth pressure contribution, and that is why we assume that that pile is rotating very close to the tip. So, that is why most of the portion of the pile is getting the pressure from the active resistance of the soil, passive resistance of the soil. So, this is the soil reaction, and again it is assumed that at any point the soil pressure or the soil reaction is 3 times sigma v dash into K p. So, here also this is 3 times and sigma v is gamma dash into z. So, this will be gamma dash into L, because z is here equal to L at that point, and we have to multiply. So, as I mentioned previous case also, this value is kilonewton per meter square. If I multiply it with d, it will be kilonewton per meter, then into K p. So, that means here also we assume that sigma v dash into K p. So, here sigma v dash is gamma into L, and then we will multiply with the d to make it kilonewton per meter into K p. Okay. And here this total passive force P p will act, and which will act at a height of L by 3 from the base of the triangle or the pile. And again here also the maximum moment will act at a distance of f from the top, but here no zero earth pressure condition is existing like the cohesive case, where top 1.5 d there will be zero earth pressure, but here that type of condition is not existing. So, the maximum moment will be here . Okay. So, there will be maximum moment. This is the bending moment diagram. So, this is F, then this one is G, and this value is M max, which is acting at a depth of f from the ground surface. So, obviously, for the short pile this M max should be less than M y. Okay. Yield moment that will not occur. So, now if I write the equations for the short pile, what are the short equations for this short pile? That means here that means total is passive resistance for the passive soil reaction, and then this is the H u. So, if I take the moment from this tip of the pile, taking the moment from the tip of the pile, then this will be H u, then plus into L plus E, that is the moment, and the counter moment will be equal to P p into L by 3 into L by 3, P p is the total active passive force. So, I can write that P p is nothing but that half into this value 3 gamma dash L d K p into L, that is the total P p into L by 3. Okay. So, finally, from here I can write H u is equal to, so this 3 will cancel out. So, 0.5 gamma dash d L cube K p divided by L plus E. So, this is equation number 1. So, what are the unknowns here? Unknowns are all values are known. So, here H u I can calculate by using these equations. But if I want to determine what is the maximum moment, as I mentioned that what are our interest? Our interest is the HU and the maximum moment, because we have to check that whether maximum moment is less than yield moment or not, because in that condition we understand whether it is be intermediate pile or not, and definitely for the short pile that is the must condition, that the M maximum moment should not be greater than the yield moment. So, maximum moment should be less than the My. Okay. And for the intermediate case, and that will occur for the fixed pile, headed pile. So, that I will discuss in the later on. But again also for the short pile, free headed pile also we have to, the condition is that maximum moment should not be greater than My. So, that means we should know the maximum moment. So, for the maximum moment, to determine the maximum moment, so what is the stress at this F point? The stress at F point is similar to gamma dash, this will be F into dkp, because now Z is equal to F, because at F the maximum moment is acting. Okay, so, this is the maximum moment actually, this is M max, okay, at F. So, I can write that HU at F, or I can write this point is F, HU at F will be equal to, or at that point this will be half into again 3 gamma dash d kp f into f. So, f square, f into there will be a f, this is the f. So, that f will come. So, that is the HU. So, I can write that f in terms of HU will be equal to, if I take f, that will be 0.82 root over HU by gamma dash d kp. Okay. Because in this case we take the moment, or we take the we balance the forces with respect to F, okay, and this HU is acting in this direction and F portion is acting in this direction. So, we can get, so once we get the HU, so we can get what will be the F value where the maximum moment is acting. So, once I get the F, so then this is my second equation. Once I get the F, then I have to calculate what is the maximum moment, and that will be equal to, so I am taking the moment with respect to F. So, taking the moment with respect to F point. So, that this will be HU into F plus E, then the counter moment is half into F portion gamma dash, sorry, this will be 3, because this is half, then into 3 gamma dash F d kp into F, this is the force, and then F divided by 3. Okay. So, if I simplify these things, and definitely this is nothing but HU. Okay. So, this will be simple HU F plus E minus HU F by 3. So, simplify this, I will get HU E plus 2/3 of F. So, this is equation number 3. So, for this short pile, free headed pile, so equation number 1 will give us the HU, equation number 2 will give us the F, because that F is required to determine the M max. So, once I get the F and the HU, then I will get what is the value of M max based on the E value. Okay. and then that you have to check definitely that M max should be less than M y. Now, I will go to the long pile case. So, I will go to the long pile case. Okay. So, long pile case, this is the ground surface, so again here there will be a yield in case of long pile at a point. Okay. So, this is H u and this value is E, this is L, fine, but the distribution will be slightly different, because here this is the point where maximum bending moment will occur. Okay. So, this is the point where maximum bending moment will occur, then it will go like this. So, this is the bending moment distribution. Okay. And this is the point which is again F, and this value is M max, and the soil reaction will be something like that. Okay. This is deflection, this is soil reaction, this is bending moment. Fine. Now, for this particular case, what are the equations are valid? Okay. So, again we assume that the lower portion, this negative positive, they are balancing each other, and this distribution is more or less linear in the top portion. So, I can write that equation 2 is valid for here. So, I can write H u will be equal to half into 3, because here we assume the distribution is, this value is 3 gamma dash d k p f. Okay. So, I can write this is 3 d k p f into f. So, H u will be equal to 2/3 gamma dash d k p f square. So, this equation is valid here, because why it is valid? Because we assume that this portion is more or less linear, and this positive and this negative, they are balancing each other. Okay. So, this is one equation. Then equation 3 is also valid, because equation 3 is also valid. So, equation 3 for previous case. So, this is the equation 3, this is the equation 3 that we can write here. So, this that we can write here, because equation 2 is also is valid, equation 3 is also valid. So, we can write here this equation, this is 2/3 gamma dash d k p f square, yeah, and this equation 3 I can write here. Equation 3 is what? Equation 3 is H u e plus 2/3 f. So, H u e plus 2/3 f. Why equation 2 is also valid? Because we are taking moment at this point f, because where the maximum moment is acting, and as we assume this is more or less in linear distribution. So, which is same as this point for the short pile. Okay. So, that means here also we assume this is linear distribution, the same way we can calculate the m x also here. So, equation 1 and 2 is valid, but what are the unknowns here? So, here m x is unknown, H u is unknown, f is unknown, but we have 3 equations. We have 3 unknowns, but we have two equations. So, for the long piles, third equation will come, that maximum moment Mx should be the yield moment. Yield moment of the pile. So, this is third equation. So, if I replace this, this will be My Hu E plus 2/3 of F, and this MY is known. So, from using equation number 1, we will get the Hu. Now, we have what are the unknowns? Hu is unknown and F is unknown, and we have two equations. So, we will get the F and we will get the Hu. So, we will get where the maximum moment will occur and what will be the value of Hu. So, so that this is the long pile and short pile case. So, now that means, if in case of short pile, if you have done the analysis for the short pile, and then once you calculate the M max, you find that M max value is greater than My, or okay. So, then that means that will be a long pile. So, in that case, you have to design it for the long pile, considering M max is equal to My, and then you have to find the all other values. So, this is the M max and the Hu, and M max will be replaced by My, and this way we can calculate the long pile and short pile case. So, now I will go for the fixed headed pile. So, this is the free headed pile. Now, I will go to the fixed headed pile and pile in cohesionless soil. So, for the fixed headed pile, first I will go for the short pile, then I will go for the intermediate pile, and then I will go for the long pile. So, again this is the ground surface, and this is the fixity of the pile or the pile cap, and this is a short pile. So, again here also the total pile will move laterally, because it is a short pile and it is a fixed headed pile. So, this is the fixed head or say pile cap. So, we are applying Hu, and definitely there will be a moment M. Okay. So, this is deflection. Now, the reaction, again here total will be the passive reaction. Soil reaction is the passive. So, this is again 3 gamma, or if it is a dry soil, I can write only gamma, or it should be the effective gamma dash L d K p. And here for the fixed end, there will be a maximum moment. So, bending moment diagram will be something like this, and this will be the maximum moment M max, because now it is a fixed headed pile. So, this M will be M max, maximum moment will generate at the pile head, and that is the same as the pile in the cohesive soil. Okay. So, now what are the equations? Now, the short piles we have to determine the again Hu. So, Hu will be equal to this total resistance. So, this will be half into 3 gamma dash L d K p into L. So, this will be Hu will be 3 by 2 or 1.5. So, I am writing 3 by 2 gamma dash L square d K p. So, this is equation number 1, and M max, if I take the moment with respect to surface. So, M max taking moment with respect to surface, and that is why this HU contribution we will not consider, because HU is also acting at the surface. So, M max will be this total passive soil reaction contribution, and this is bending moment. So, that will be total is HU, because this is half into 3 gamma dash L d K p into L into 2/3 of L, because it is from here, from the base it is 1/3, from the top it is 2/3. So, that is the moment, and this is nothing but HU, because this is nothing but the HU. So, I can write that M max will be equal to 2/3 of HU into L. So, we have calculated HU by using equation 1, and we will calculate maximum moment using equation 2, and you have to check whether maximum moment is within the yield moment or not. Okay. Now, we will go for the intermediate pile, and for the intermediate pile, okay. So, for the intermediate piles, again this is the ground surface, and this is the fixity, and this is the pile, and again like the cohesive soil, it will rotate with respect to a point. Okay. So, with respect to a point, and then again we are considering here the all passive resistance only, active we are not considering, and rotation is very close to the tip. So, the resistance will be, passive resistance is this one, and where will be the maximum bending moment? Maximum bending moment will be at a distance of f from the top, like the previous case, but yield moment will start at the pile top or pile head. So, this will be the diagram. So, this is the diagram, bending moment diagram. So, this value is M max, okay. So, this value is M max basically, and this distance is f from the surface, and this value is M y, okay. And this is obviously again 3 gamma dash d L K p, because this is L, sorry, this is L. So, there will be H u and there will be M y, okay. There will be M y. So, I can see that whether all the cases M value properly or not. So, let us see for the previous cohesive soil short pile there is no M. So, this is for the short pile fixed headed pile. So, there will be one moment here, okay. So, that moment I may be mix. So, that is max, M max. There will be one moment for here, this will be M y, here again this will be M y, fine. Okay. So, now I have to consider here this is M max, fine, this is M y, okay, fine. So, now if I take one reaction, because here tip is moving. So, if I take one reaction force F at the tip of the pile, because the pile is rotating as close as tip of the pile. So, now I can write in case of intermediate. So, intermediate case, that definitely M max is greater than M y for intermediate case. If M max is less than M y, then it will be a long pile case. Okay, I have discussed. So, this is the M max is greater than M y. So, F force, what is this forces? So, this force F force, I can write this reaction force F is equal to this total one minus the H u. Okay. This total one is half into 3 gamma dash d k p L square is the total one minus H u is acting in the opposite direction. So, that will give me the F. So, I can write F is equal to 3 by 2 gamma dash d L square gamma dash d L square k p minus H u. So, this is equation number 1. Now, this yield moment will be at the top. So, taking moment with respect to surface. Okay. So, what will be that moment? So, this is the F is acting. So, F into L length minus this contribution, because H u will not consider, because it is also acting at the surface. So, that contribution is nothing but half into 3 into gamma dash d k p L square, okay, into this is 2/3 of L, from the top 2/3 of L. So, this is nothing but these contribution, or I should write the total one. Here the replacement scope is not there. So, this moment is we are taking at the surface, and surface moment is equal to m y, because at the surface this moment is m y. So, at the m y yield moment at the surface is this one. So, now we have to replace this F by this equation number 1. Now, if I replace this with equation number 1, so I can write that m y is equal to, I can replace this equation number 1, and that is 3 by 2 gamma dash d L square k p minus H u into L minus these 2, 3, 3 will cancel out, gamma dash d then L cube into k p, because these 3, these 2 will cancel. So, this will be equal to 1.5 gamma dash d L cube k p minus H u L minus gamma dash d L cube k p. So, finally, it will be this is 1. So, 0.5 gamma dash d L cube k p minus H u L, and this is known. So, by this equation 2, I can calculate what will be the value of H u, because m y known, all the other factors are known except by H u. So, and if you want, you can calculate what will be the m max at a point of F from the top, and then you can check whether that m max is greater than or less than m y. If it is less than m y, then definitely intermediate pile. If it is greater than m y, then it will be long pile. Okay. So, m max should be sorry, if M max is greater than My, then intermediate pile. If M max is less than My, then it will be a long pile. That means, if My is greater than the or less than the moment which is induced at point F, then it will be a long pile. So, that means, if this is the case, then intermediate piles, or if M max is less than or I should write that this point it is this should be less, that if the moment which is induced, because here also you can see that for the your this case for the intermediate piles, that M max should be less than My. Okay. So, here also that M max should be less than My. So, M max should be less than My, then it is intermediate pile. Okay. This is intermediate pile. Otherwise, it is long pile. So, that means, if M max is greater than My, which was the condition previously written, in such case it is a long pile. Okay. So, it will be a long pile, but generally we will restrict it to M max is equal to My for the long pile, and that I will discuss in the next class. So, that means, here we have from equation 2 we can determine what would be the value of HU, because My is known, and then we can calculate the M max, which is acting which will induce at a depth of F from the surface, and then we will check whether it is satisfying the intermediate pile condition or not. That means, the M max should be less than My, then it is the intermediate pile condition. Otherwise, if M max is greater than My, or if it is not less than My, then it will be a long pile. But in case of long pile, we will consider M max is equal to My, and that I will discuss in the next class. Thank you.